Hi, everyone.
Hi, Anu. We can hear you perfectly right as well. Excellent. Okay, everyone. So first of all, again, thank you for joining us today. This is the 66th edition of this meetup, the number 66 today. This is the April edition. And for today, we have a very interesting session on MuleSoft sizing guidelines with Anu, as you already know. From the meetup team that organized these sessions, we have Manik and Sandeep hosting the sessions from Americas. We have Royson from Asia, specifically Singapore, and myself from London. There is some things to keep in mind. Keep in mind that the trainings and certifications, you can find them in trainings.mulesoft.com. You have the help.learn.mulesoft.com for all Muleys. This is a new resource since last year or a year and a half ago, where you can submit any query you have about training, vouchers, any issue that you're having, you can submit it there. Then the two places, the forum that you can still use, help.mulesoft.com, or the Stack Overflow for anything that is data, we highly recommend it. So the guidelines for today, you can pop your questions in the chat and anyone from the community can try to answer. The remaining questions will be asked in your behalf at the end of the session. And keep in mind, there will be a recording both from the session in the Meetups page and in the Virtual Muleys channel. We will also upload the slides that you're seeing today in the Meetups page where you register for this event. There will be a publication on LinkedIn afterwards as well. And your feedback at the end of the session drives the future content of these meetups. You can always feel free to add your ideas, your thoughts, your opinion. Now, for today's session, I'm taking too long so far. It's 2 minutes. We have 3 minutes of announcements and updates. And I wanted to let you know again that there is the MuleSoft Certified Developer coming at end of April. This will be a certification of level 2 for our MuleSoft developers. This is new from the training team, and it will be announced by the end of this month. There's also some other points related to training that are very important that we remember. That is a 3 days fundamentals course. There's also the certification attempt once you finish your MCD. And there's a new modality that is flex training. So the training team offering flex courses that take place over the weekend, meaning not during the weekend, but Friday and then Monday, Tuesday, for example. Very quickly, a reminder of the MuleSoft recommended support process. I know for some of you it's extremely obvious, but I'm still having issues with some customers nowadays that are finding problems. They don't know how to debug, and this has proven to be very useful. There is a second point related to, oh, I'm not sure what happened there with the slides, but the announcement of Studio 7.12, it happened the end of last month. And interesting. Of course, it had to happen. Let's continue. There's also a accelerator, MuleSoft accelerator, that is published into Exchange. You will find the links there to find the resources I'm mentioning. This one is related to manufacturing specifically. What is interesting actually is that you will find the sequence diagram. You will have an architectural component, the components diagram as well, UML, there on how the components interact and how your API-led can facilitate, this accelerator can facilitate API-led for manufacturing industries. There is also Anypoint Data Graph release coming that already happened on March 21st. There were two main points that were released. If you're interested and you're already using the technology, you can find it there as well in the link or in the, this is all to the public documentation. Now, on an announcement, an important announcement will happen at the end of this month, an update on something we discussed previously, that is Universal API Management, and specifically one of the products, Flex Gateway, that many of you are interested. This is basically API Manager for non-Mule APIs. Deploy has an agent in Linux OS, for example, in Docker, or has an ingress controller for Kubernetes. So this there will be an update by the end of this month. And keep tuned if you're interested in this technology, which is actually one of the most exciting releases, in my opinion, including Cloudhub 2.0, that are planned for the first half of this year, meaning before July. There was also a point on the MuleSoft benchmark 2022. The report is available if you were in PKO. I was already mentioning when you need to justify APIs, technologies to your leadership. This is a great document. And if you want to understand what is going on in the market, what are developers, integration teams looking for? I'm not going to dive too much. We already spent 6 minutes. So these are some other news from general things that are happening in MuleSoft. This will be related to Catalyst articles. So you have one on C4E metrics there at the bottom right. I will say this is one of the most crucial and important ones, considering KPIs and metrics toolkit popularity nowadays. Now, with that said, I'm not sure what happened with the slides. I'm very sorry because of these image issues. But for today, we will have Anu. And she has been a very often a speaker in these meetups. Hi, Anu. And here's a little intro. Anu, I don't know if you want to run through it.
Sure. So I am American born. I've been based in the UK since 2008. I've been working for as long as I can remember. And it is true that before I joined Mule, I was in delivery and professional services for Appian. This should now say 2.5 years ago, as I joined in 2019. But yeah, I'm old like the furniture now.
Yeah, almost there. I know, 3 years. Incredible. Thank you very much for that. And again, I just the screen, and thank you very much for stepping up and coming to the community to share your knowledge around the MuleSoft sizing guidelines. You should be able now to share the screen.
I'm having some technical difficulties. 1 second.
So today is the day. I was having the issues as well with the slides. Don't worry.
Yeah. Let's see. Okay, I think I got it. Can you see my screen?
We can see it perfectly fine, and we can hear you perfectly well.
Great. So today I want to go over the sizing guidelines for MuleSoft. Oftentimes when you start with MuleSoft, you have a solutions engineer that comes and helps you with sizing, but once you get going, they're not always going to be there. So it's better to arm yourself with that knowledge so that you know how to size properly. And so we're going to cover 5 things today: the core concepts of sizing, factors that impact Mule sizing. These are reversed. We're first going to go over the sizing nuances of Cloudhub, OnPrem, and Runtime Fabric, and then t-shirt sizing, and then we'll cover high availability and how that affects sizing. And at the end, we'll have hopefully time for questions. So in order to level set, let's discuss the core concepts of sizing first. What is a Mule project? It is a project that is authored by a developer using Anypoint Studio or Flow Designer and includes integration or API logic. And since a Mule application or project is a single deployable unit, it is normally has its own development, test, and deployment cycle. It's treated as a product. Note that API proxies created in API Manager via one-click deployments are also considered Mule applications in this context. What is a flow? A Mule application is comprised of one or more flows. Each flow might be an operation for a REST endpoint, an operation for a SOAP web service, a scheduled batch task triggered by a timer, or an event-driven task triggered by a file, a row in a database table, or something like that. Flows can be split into subflows for clarity and reuse. An API is normally provided by one Mule application containing multiple flows. In addition to the endpoints, a Mule app providing an API might also contain closely related flows, such as scheduled data synchronization for the same system or process API. What is a transaction? A transaction is a single invocation that passes through the flows. Transactions can cross multiple components during the flow, cross multiple flows if the main flow orchestrates subflows or other flows, or be a one-way or request response. For flows that make up an API, operations such as get, post, and delete each count as a single transaction. In this instance, we are not referring to atomic units of work that can be rolled back. A transaction or transactions per second are industry standard terms when discussing sizing as well. We'll use TPS later on, but you might choose to think of TPS as messages per second. Now to review the three most common types of deployment models: on-premise, runtime fabric, or Cloudhub. On-premise refers to any standalone Mule server worker or any virtual or bare metal server in any cloud or any data center, but not in a MuleSoft iPaaS Cloudhub, with a runtime agent enabling communication between on-premise workers and the management plane, and a shared JVM server resource for all deployed Mule apps. Runtime Fabric is a Kubernetes-based orchestration of multiple Mule runtime containers deployed across any cloud or data center. Applications are isolated, scale horizontally, and redeploy with zero downtime. Cloudhub applications are run by one or more instances of Mule called workers. Each worker has a dedicated Mule runtime in a separate virtual machine with a specific amounts of capacity to process data with a specific number of workers. Isolation in a separate container from other applications, independent management, deployment, and monitoring, and a specific locale worker cloud, say the US, EU, Asia Pacific. Workers are dedicated Mule runtimes. Each worker is a separate virtual machine that are protected from external access via SSH with no file system access allowed, and the number of workers is automatically balanced across availability zones. Cloudhub manages worker provisioning and scale out. Another thing to consider in an on-premise environment is how to organize your APIs. As a monolith or a microservice, isolation requirements of your APIs have an impact on your cores and your sizing. A monolith runtime will have multiple related or unrelated APIs or integrations deployed onto one big Mule runtime. For those who have been using Mule for a long time, you may remember that this is how Mule ESB was historically deployed. This was the only option for legacy on-prem vendors like Oracle, IBM, webMethods, etc., that run all integrations on shared application servers. And this is how a naked Mule is deployed today. There are some drawbacks to this approach, of course. First, undesired dependency between line of business tenants. For instance, a rogue non-business critical integration deployed by HR could introduce a runtime error, like a memory leak, that brings down all integrations across the company, including, for example, business-critical e-commerce apps. Next, noisy neighbor. APIs with unexpected peaks could take away processing capacity for all other APIs on the same runtime. There's no dedicated or reserved capacity per API. Lastly, an upgrade of a runtime will require every tenant to be on board. For instance, if Team A wants to take advantage of the new features of a 4x versus their current 3x shared runtime, it will require every tenant to take on that upgrade and that migration project to Mule 4 and retest. The pros of this approach are that it allows packing the highest number of APIs per license core, since there's no core density limitation like with Cloudhub and RTF. And for budget-constrained customers, that this is likely the only option. A microservices compliant runtime, which is the other option, will ideally have one API or integration deployed on one container, one-to-one. I apologize, it started hailing. You can hear that in the background. I can't do much, but anyway. This gives autonomy to business domains to operate independently, including scaling individual services up or down versus an entire shared runtime. The pros of this approach are isolation of applications, avoiding the problems of the monolith architecture that we just talked about. And it also complies with modern architecture like domain-driven design. However, that could mean dedicating an entire machine on-premise or container, in the case of RTF, per app, so more infrastructure overhead per application. In some cases, this can translate to lower core density and higher license costs. Everything is a trade-off, isn't it? And a note about vCores versus cores. MuleSoft is licensed based on the number of cores needed to run APIs or integrations as Mule applications. MuleSoft treats physical and virtual cores as exactly the same. So now that we've level set and we've covered the core concepts, let's discuss the factors that impact mule sizing. This is the exciting part. Before you begin, there's a few points to emphasize. Your sizing exercise should account for peak usage to ensure stability of the application when spikes occur. Please be aware that the sizing exercise is purely an estimation, and it is impossible to predict the exact amount of cores that will be required. And it is important to document all of these choices and agree any assumptions across the business. Now let's discuss what factors need to be considered when doing a sizing. First, the number of APIs or the Mule applications to deploy. Second, the peak volume or number of transactions per unit of time, whether that is seconds, minutes, hours, or days. Third, the payload sizes of your APIs. Fourth, the business logic complexity contained within each API. Next, the SLA set out in your requirements for the API. Also consider that there are various other factors outside of MuleSoft's control that affect sizing and performance, like network latency and security. Also consider your integration patterns. Are you developing batch integrations or real-time APIs? Another factor to consider is your deployment model. Are you using Cloudhub, Runtime Fabric, or on-premise runtimes? And lastly, remember that you will also need to factor in cores for your non-production environments. Now, we will go into these factors into more depth. Transactions per second, or TPS, is a key metric that drives sizing requirements. The more transactions going on at the same time, the higher number of cores will be required to meet the demand. Account for both peak TPS and average TPS. For peak TPS, factor in how often and how long the peak time periods are. For perspective, even though it may sound small, 20 TPS is a huge number, approximately 1.7 million hits per day. This is an uncommon need for most integration use cases. Payload size in kilobytes is the most common measurement. Larger payloads will require more CPU, more I/O, and more in-memory to send, process, and receive. Memory management adds overhead, and large payloads may be impacted by network performance. For example, with all else equal but the size of data, transactions with a payload of 1 megabyte will take longer to process than those that are 1 kilobyte. Also, payload is inversely proportional to transactions per second. The graph here illustrates that TPS over payload size for a simple application is 1 Cloudhub vCore. As you can see, the bigger the payload size, the fewer transactions per second you can perform, given the same size of 1 vCore. Complexity is the amount of logic required to perform mappings, routings, and data enrichment for integrating one or more applications. More complex logic drives more CPU resources and time to process. There are 3 levels of complexity. Simple is categorized by pass-through proxy or sequential operations on single payloads with little or no routing logic and simple or no data transformation. For example, a mobile experience API. Usually, experience APIs are simple APIs because there is no need to transform, as these APIs typically reuse the same schemas that are used by the process and system APIs that they invoke. Medium complexity indicates enrichment and orchestration of 3 to 10 systems or services with routing logic and medium complexity data transformations. Complex would include orchestration of 10 plus systems or services with complex data enrichment, aggregation, and complex routing logic. SLA is the expected response time of an API or an integration processing and impacts sizing in a few ways. Typically, strict SLAs with shorter expected response times will require more resources to process any given workload. For example, a 2-second response time at 1000 TPS will take more CPU resources than a 3-second response time at 1000 TPS in order to alleviate resource contention. If the flows make external backend system calls, for example, to a database, a web service, or reading a file, the overall response times will be dependent on the response times of those external systems. Be aware that external factors such as network latency and security around those systems could affect the latency and therefore your overall response time. In general, more back-end latency requires more resources, i.e. a bigger worker, to attain the same level of throughput. or TPS. This is because the number of blocking I/O threads that are listening for incoming requests and keeping the connection open to respond back to the API clients is directly proportional to the size of the worker in terms of the number of cores and physical memory. Therefore, a bigger worker can open more I/O threads. Longer back-end latency would require each thread to keep busy longer and therefore will eventually run out of threads in the pool. In this scenario, in the chart, the new incoming requests start to get queued up, waiting for an I/O thread to become available. As the queue grows longer, the average response time gets longer as well. This is called back pressure and leads to a negative impact on the SLA. Another thing to consider is your integration patterns. Batch is the bulk processing of data, typically scheduled or triggered without manual intervention. The key metric for batch is the window length, or the SLA. Processing 100 million records without a hard SLA timeframe means potentially a single core. Even a fraction of a core on Cloudhub could do the job. Processing 100 million records, the same amount, with a 4-hour SLA, equates to 6,945 TPS, or maybe 26 to 28 cores. So think really carefully about how quickly you need your batch to be done. Real time typically implies a synchronous response, like your standard API. Synchronous means sending a response for each message received and is only as fast as the slowest step. Asynchronous, like pub/sub, means when Mule receives a message, it does not have to send a response and will generally be more performant. Going back to batch for a minute, please note that apart from the regular Mule flow, you can always also use the Mule batch module to do batch integrations. The batch module works through 3 phases: load, process, and completion. I'm sure I've done this in another meetup. There's definitely a video that I've done if you want to go into further detail on this. But during the load phase, the source data is stored into the persistent disk of the worker and then loaded into an internal queue system, also using persistent disk. This makes batch processing highly reliable, allowing it to restart from a failure point in case of failure during the process phase, which means you could potentially allow your SLA to be longer. However, this dependency on disk also affects your sizing, and it requires you to consider appropriate cloud worker size depending on the size of the batch payload. Cloudhub workers of different sizes come with different disk space. The takeaway here is everything has an effect. Now, moving on to the sizing nuances. So every deployment model has a different effect on how you do your sizing. Let's start with Cloudhub. When deploying to Cloudhub, you can of course click and configure your vCore sizes from Runtime Manager. You select your region, your worker size, and your number of workers from 1 to 8. The available worker sizes are 0.1 vCores plus 500 megabytes of memory, 0.2 vCores plus 1 gig of memory, 1 vCore with 1.5 gigs of memory, 2 vCores with 3.5 gigs of memory, and 4 vCores with 7.5 gigs of memory. Note that the default shared load balancer throttles requests at 500 TPS. So if your app needs more than that, then you need to get a dedicated load balancer. In general, it is recommended to size for peak, as discussed previously, to safeguard against failure during that peak. Of course, sizing for peak usually results in bigger workers in all deployment models. However, in some cases, in Cloudhub, the bursting feature of 0.1 and 0.2 vCore Cloudhub workers may allow using these workers for way higher throughput than these can normally handle. 0.1 and 0.2 vCore workers are burstable EC2 instances in Amazon Web Services of types T3 micro and T3 small respectively, and can deliver highly dynamic performance. Burstable workers deliver a baseline performance of a fraction of a CPU, but can burst to full CPU for a limited period of time, which is determined by the available CPU credits, delivering way higher throughput than baseline. This allows for handling of peak traffic if it falls within the timelines of the bursting period. Consider the following hypothetical example. A retail customer is asking to size for Order API to handle average TPS of 200 and a payload size of 100K. Let's assume that the 1.1 vCore can handle this load just fine. However, the customer also informs you about a 6x more peak volume that could last up to 30 minutes per day. Taking advantage of the bursting capacity of a 0.1 vCore worker, you can suggest to them to use it instead of a bigger worker. There's some more nuances this time to be aware for on-premise Mule servers. There's a minimum of 1 core per instance, but 2 cores are recommended to take advantage of all of the hardware resources. The rule of thumb is a max of 25 lightweight applications per core. If there are heavy ETL processes running and strict SLAs on sync APIs, consider separating your real-time flows from your batch flows onto different runtimes, because you'll end up with a noisy neighbor issue. Greater core density is achieved as you deploy multiple applications to the same Mule runtime. Note that high availability, which we'll get into later, on-premise is best accomplished by deploying Mule apps to a cluster or a server group. The drawbacks to these nuances are poor environment management experience, as upgrades are not automatic. One badly written Mule application can take down your entire server, and you may experience downtime when upgrading and deploying Mule applications. Now, Runtime Fabric. A few things to consider when deploying applications to Runtime Fabric. You'll need to specify the amount of capacity to allocate per replica when deploying applications. A replica is an instance of an application and is synonymous with a worker in Cloudhub. Each replica will only have access to the specified amount of capacity, irrespective of the amount of CPU available on each worker node. Reserved CPU is the minimum amount of capacity that each replica will be allocated, and CPU limit is the maximum amount of capacity the replica may burst to, assuming there's enough spare capacity on the worker node. If CPU limit is equal to reserved CPU, then bursting will not be allowed. There's a few limitations to RTF as well. First, controller nodes. The maximum number of controller nodes supported is 5, and the maximum number of worker nodes supported is 16. And the maximum number of replicas that can be deployed to per worker node is 40. The rule of thumb is to run no more than 20 to 25 replicas per core, up to a maximum of 40 per node for simple applications, and to allow core sharing across replicas when needed for bursting. This ensures Runtime Fabric's internal components that run on each worker node are not overloaded by too many replicas. Also, the maximum number of associated environments per Runtime Fabric is 50, and the maximum number of Runtime Fabric instances you can create in the business group is also 50. Let's take an example. I learn really well by example, so hopefully you will too. Anypoint platform-based subscription customer is licensed for 2 cores of Mule in production. So the RTF deployment here would be 2 worker nodes with 2 cores each. Each worker node has approximately 0.5 cores reserved for internal services, leaving approximately 1.5 vCPU per worker node. A total of 4 cores minus 1 core reserved for internal services equals approximately 3 available vCPUs. With Runtime Fabric 1.6, customers could deploy up to 20 simple applications, which is a rule of thumb, per CPU core onto Runtime Fabric, which reserves 0.02 CPU and limiting bursting for 2 vCPU or higher. With 2 worker nodes, there's approximately 3 vCPU used to deploy Mule apps. However, each worker node only has 1.5 vCPU available, so that's the most an application can burst to. The total available vCPU is 3, so customers must look at their application CPU utilization to ensure, in aggregate, that no more than 2 cores are used at any given time. Now that we've covered the nuances of sizing for deployment models, I want to go over t-shirt sizing. Much simpler. The t-shirt sizing approach works by categorizing and counting the number of Mule apps under predefined set of sizing parameters combinations called t-shirt sizes, small, medium, large. If you're familiar with Agile, it's a similar concept. Each t-shirt size is assigned a recommended core size for deployment. A rough sizing estimate can then be derived as the sigma of the number of apps under each t-shirt size multiplied by the recommended core size of the t-shirt. There are two kinds of complexity measures. If the customer doesn't know the details of the program of work, but at a very high level knows that they have to build n number of integrations, then the complexity can be defined based on how many integrations this program of work will require. For example, in a greenfield project, say for example they have 3 programs of work and the number of integrations determined in total are 30, 20, and 10. For a sizing estimation, we can start to divide our complexity with the size or the total number of integrations. In this case, they have 3 programs with the scale of complex, medium, and small. Our services team uses this approach for both sizing and after estimation. At the next level of discovery, we start to get into the details of each project so that we know from a Mule implementation perspective how complex this piece of integration is going to be, and then our complexity is defined based on the actual use case implementation as defined in the chart above. Point 1, the t-shirt sizing can be used as a start when we come across customers who don't have much detail around their implementation. The chart in this slide covers point 2, and the detail below, which I'll describe to you, with some examples and concepts on how we can use the approach described in the chart. For example, if the current project has 30 integrations, 20 of them are small, 5 medium, and 5 complex, we are roughly looking at anywhere from 12 to 20 cores, depending on the high availability requirement for each of these apps. This can become more granular and specific if we know the total domains or the backend systems that are part of those 30 integration use cases. Let's say we have 3 backend systems. We can start with a minimum of 3 system APIs, 1 experience API, and the rest of the use cases may fall into the process API bucket. There's no magic formula here, and I think that's the key takeaway from this presentation. The more detailed technical discovery we have done, the more we can get into the nuts and bolts at an API level. There's lots of assumption, but it's a good starting point, and that is the total number of integrations. The next step is determine how many are real-time, how many are batch, can we bundle multiple batch integration use cases into one Mule application, things like this. So it's not an exact science. Moving on to high availability, which is my last section, and then we'll take questions. High availability refers to deployment choices that are made to achieve operational resiliency, typically in terms of uptime. The business must define this requirement. High availability involves removing single points of failure, such as API workers, by deploying spares. While one fails, another is still available, avoiding a failure of the overall system. Load balancing to share requests between workers, or fixing failures promptly. When one component is down, the system is temporarily vulnerable to failure of the survivor. For example, instead of deploying 1 API worker, we can deploy 2 and load balance between them. If one goes down, the other keeps processing the work alone until the first one recovers. So when to use high availability? Cloudhub provides 99.99% availability as standard. So this allows 52 minutes and 36 seconds of downtime per year. The SLA provided for on-premise completely depends on your own infrastructure. If your business can tolerate the service going down for a long time and there's a plan in place to fix it, then you probably don't need high availability. But if your business requires 24/7 entirely uninterrupted service, then they need high availability. Things to remember about high availability: it requires protection end to end. There's little point of having a highly available Mule API if your network or your underlying system is unavailable. So horizontal scaling is another deployment choice. For high availability to work without degradation of service, the peak workload should also not exceed what the worker can handle after allowing for one of them to be down. So in that case, you might want to consider horizontal scaling for both performance and availability requirements. Scaling can be used to achieve high performance or high availability, or both at once. Consider a hypothetical Mule application that processes 100 TPS, deployment A in this example. Deployment B can be used in 2 ways. The Mule apps can be fully loaded to scale to 200 TPS between them, or one Mule app can take over if the other one fails, but in that case, the total load should not exceed what one Mule app can handle. i.e. 100 TPS. Like B, deployment C can be interpreted in two ways. It can scale to 300 TPS, or in the case of failure, there are two surviving Mule apps, so it can provide high availability up to 200 TPS. Non-functional requirements determine whether high availability is needed. Our approach can be very broad brush or very detailed depending on the scale and the information available. High availability, simple sizing. For small or low volume deployments, we can use a rule of thumb. It is double your number of cores. For deployments with many APIs, high availability is normally needed only for certain use cases. Agree on the assumption with the business. HA is only needed for, let's say, a percentage of your APIs, then you would only need double your cores for that subset. High availability, detailed sizing, and high volume. So in large deployments where APIs have scaled horizontally to handle volume, you can double everything, but this is very pessimistic and not always affordable. Consider which APIs do need high availability, and is there a reduced SLA acceptable during a recovery? And do you need double cores, or is adding a worker sufficient? Do you have any questions? That's my last slide. I know I talked a lot.
Excellent, Anu. No, not at all. The presentation. We do have, however, around 3 questions so far. So if you don't mind, we will start. The first one is from Pippin.
Okay.
And the question is, can there be any number of runtimes on a virtual machine or a physical system? Is there a relation between number of cores, licensed, and installed runtimes on a single system VM, irrespective of CPUs?
Oh, that's a good question that I don't have the answer to. Let me get back to you. Angel, if you don't mind writing that one down, I can follow up.
It's already, I'm guessing it's related to licenses, and that's not our core. That's fine. The next one will be from Craig, and the question is, it is possible to run more than one runtime on a single core. I'm not sure if it's recommended or not and supported on a production environment, because, and he adds one of the articles that mentions what are the concerns of it. So the question here would be related if it's possible to run more than one runtime on a single VM with a single core.
I wouldn't do that if I were you. I'm a big fan of the microservices approach, one-to-one. It's not always feasible, but it is best practice, and it is the right modern way to do it. So
yeah, and there's adding on that one as well, the way that Cloudhub works, for example, that you will spin up your whole Mule runtime and then you will put an application on top of it. We have seen customers that are on-prem when they're trying to run with 50 plus applications in the same server, that they start experiencing a bigger degradation. So these are also things to consider.
yeah, so the slide about noisy neighbor and one of your apps taking down the entire server, those are things that you would have to worry about if you started packing your runtimes.
Thank you. There's another question coming from Chaitanya. Apologies for the pronunciation of your name. Is there any way to look at memory and resource consumption of a single application on premise? More applications running on a single server.
So are you using Runtime Manager? I would think that would give you the data that you were looking for.
I would have thought the same, actually. Chaitanya, if you can confirm if you're able to use
I'm missing something.
Manager. Unless we're talking about a headless deployment.
Runtime Manager. Oh, and then I don't know, I can't help you. No, I'm kidding. I'm sure you could like do some scripting and some performance testing to understand more if you were going headless, but I'd recommend using Runtime Manager because that is all out of the box. So
Thank you, Anu.
Tony, unpack those runtimes.
runtime packer. We have another question coming from Vimal Raj. RTF deployment are failing even after following the t-shirt sizing approach. Let's say we're using a medium t-shirt size. However, the deployment is still failing. What could be the possible reasons?
So do you know why it's failing? Is it failing while under peak load, or is it failing under normal circumstances? Check the memory, check the CPU. Angel, can you think of anything else? I'd say performance testing is always the answer. Initial deployment, okay.
The question here, Bimal, right, will be if it's related to actual sizing or is it something else going on? Are you able to run the applications?
Yeah,
Because it doesn't seem, yeah.
So it could be anything. It depends on what the like what is the error message that's giving you when you deploy it. I would recommend maybe opening a support case as a start. Oh, okay. So perhaps your API is very complex. There's maybe large data weave or lots of things that require memory. That could be the answer.
There's also, I'm adding one that was a great article from Sandeep that may help in this case is when we need to think about the differences between on-prem deployments and RTF. But when we talk about RTF here, it's based one on VMs, actually. It's not bring your own Kubernetes. That may help as well. We have another question from Onkar. Are there any metrics for how Mule applications should perform in RTF? Is there some sort of documentation for this?
Metrics. So we do have some performance benchmarks. I don't know if it's specifically for RTF, but I can dig those up and have Angel send that out with the rest of the deck.
I know you're referring as well to the MuleSoft white paper on tuning, performance tuning.
Yeah, I don't know if that's specific to RTF though.
Yeah, because I don't think we have any publicly released documentation about what Onkar is specifically requesting around RTF, because the challenge that we will have there is that when you're choosing the underlying OS, there's a lot of other constraints and variables. So that's where I will see the challenge. I don't think we have any resource besides the white papers are specifically around performance in your runtime, not to the point of RTF. As you in RTF, you can even have your auto bursting, configure auto bursting. And if we talk about BI with YO Kubernetes, bring your Kubernetes, you have other even more variables, including the load balancers, how you configure them. I don't know, Onkar,
Yeah,
if
there's
you're...
a lot of
Sorry.
I was just gonna say there's a lot of factors, so it's hard to benchmark that.
Thank you for completing there. And okay, yeah, we will send that the performance white paper. It seems Onkar, it will be useful for you. I will also be making an article of the links that we shared today, so you have it at hand when we publish the recording on the deck. And we have another question from Vikrant. In terms of sizing and managing load in production, we can also use auto-scaling approach in Runtime Manager. So theoretically, I can, with a smaller size mule worker, and then scale out based on actual load. Any feedback on this approach?
I thought you needed an ELA for auto scaling, but you can do that, yeah, in Cloudhub.
Yeah, that's a topic that I have worked in the past. So you have to exactly as Anu mentioned, there's one way that is when you have an ELA, which is the Enterprise License Agreement. It's on indefinite peakers, and then you have this feature to scale up and down automatically. But otherwise, you can use the platform APIs, Anypoint CLI, in combination with the runtime alerts. So when you receive an alert, you can do an action. And then after a time that you define, you can reduce the worker. This is usually for customers that already have a pipeline up and running. So it's easier. If you're starting from scratch, you don't have any sort of automation, it will be definitely cumbersome. So the suggestion there is to allocate a bit more. There's also a point there we should always be careful. And I sorry to hijack your session, Anu, but this is because I had this issue recently
No,
with.
it's fine. I need a break from talking, so go ahead.
Fair enough. You have done already almost the hour. Um, so the point with the peak, when it's a fractional peak, when we talk about less 0.1 or 0.2, you need to be aware that there's some CPU credits on it. And the design of the applications itself, you usually should think about applications that are going to use a search period and then they're going to rest. If you need more information about this and how the CPU credits work, you can also check the resources from AWS Original, and you will find how it's the same person that is being used for these instances, fractional vehicles. Now, we have another question from Chetan. It is not for vehicles, but related to performance still. Runtime Fabric doesn't provide rolling restart for an application deployed on Runtime Fabric. So we have to stop and start with Runtime Manager. How can this be avoided? Because we use an external property file, so for any update to those, we need to stop and start.
I have to say I'm not an RTF expert, so I don't know the answer to this one either. But
Yes, so there's an there related to that one that is not with sizing actually. The question would be if you can reach out to your customer success manager in that account so that they can help you meeting the right resources, because there it sounds that you could try something like such as Anypoint CLI or platform APIs or the property hierarchy, because you're talking about externalization of properties, and properties could be injected as well at runtime, right? And then you restart the application. This is one idea, Chetan, but the best would be to reach out to the customer success uh, account manager in your specific customer or company. Sure, you're welcome. Vikrant, yes, we will share some documentation around it. It's likely based on the MuleSoft support article. And we have another question related to blue-green deployments approach. I'm not sure if this is touching anything related to sizing, actually.
come on. I can answer this Vimal Raj's question. Can we use 2 replicas with medium t-shirt and 1 replica with large t-shirt sizing for RTF deployments? You could, but I don't know why you would do that. I would recommend taking a deeper look at your application and understanding the nuance of the sizing rather than sticking with these large t-shirt, large medium t-shirt. That's only used to be a first step, right? So consider what the application does, what the TPS is, what the payload is, basically all the points that we discussed in this presentation. And once you have a deeper understanding of your application and the size that it needs, then maybe you'll know better what the deployment should be.
Thank you, Anu. And going back to Vikrant, so one tricky part of the blue-green deployments is that that is not an out-of-the-box, right? It will depend a bit on your architecture. And for example, when you do have some dedicated load balancer, or if it is on-prem RTF and you can manage the traffic on your own terms, we're not talking about the shared load balancer and you're just redirecting all the traffic there. You could actually set some rules to move the traffic around. And the way you can do that is whether altering the load balancer or as well using some platform APIs, if you're using the dedicated load balancer, to make some changes there. I don't think it's ideal. There will be different ways to set up your blue-green deployments. And as an architecture, it has some challenges because it depends as well how you're doing release management, because it varies a lot between companies. And once you cover that part, because I'm guessing you're referring as well to the Martin Fowler on the blue-green deployments that they have. It's a very, very famous article. So that is one way that you can approach it, whether through API, platform APIs and endpoint CLI to make that change. But it's not an out of the box that you can configure, hey, I want 30% of the traffic just to go to this duplicated API that is version 2, while I have the version 1. Yes, Chetan, you're welcome. Yes, it seems there is a RTF season now. Actually quite timely, because when we think about Cloudhub 2.0, there will be some inner workings, but actually, yeah, mostly will be a black box, but in the inner workings, it will be all RTF. Because if you have more, if you want to actually design that architecture, I will suggest again, there should be whether the professional services team or the customer success manager will be able to put you in contact with the people that can help you in that. Depending, if you're a partner, you can talk with your partner manager. They may have some resources available to help you. Okay, Tim, I don't know if there are any other questions. If you have, please pop them in the chat. Okay, otherwise, I think I will hijack the session a bit, because Anu mentioned many interesting things, and actually your questions made me remember a couple of customers I work with, specifically when we think about, yeah, I want to do the sizing. There's the theoretical part, there is the performance part, as Anu very well mentioned, and you also...
Oh, yeah. Love performance testing.
Yeah, we do
Go
have
ahead.
a session,
I was
right?
joking around.
You created a
Yeah,
session on
I'm
the
sure
7 steps. Yeah, and
I don't know if I've done it at a meetup. I can do, maybe next time.
yeah, let's see if the feedback from the session, there's any interest on a session around profiling and performance tuning. So this is just an example, because there's a couple of topics that we discussed today, and make sure that when you're doing your performance testing to see how your application can work best, you think on the attributes that Anu mentioned: payload size, memory configuration, but you also think about the different combinations you have with the vertical and horizontal scaling, right? There are applications that cannot be horizontally scaled because of restrictions or constraints you may have, but you should try to see which one performs better. Is it having the 0.2 beacons, or is it having 1 beacon? Sometimes you will be surprised to understand the behavior of your own system. This is coming from the nature of the transactions as well. There were some other points on tuning that Anna mentioned as well a bit around the batch processing, for example. There's the data weave, that different transformations will require different timing. There's the scheduling. There's the when you're logging, if you are having log forwarding, it will be different depending on how many systems you're configuring your log for your appender, for example, or if you're doing debugger. there's policies as well. And very quickly, just to close with this one, it was policies. Remember, there's an impact of policies in microseconds, mainly seconds in this case. Every time you put a policy, there will be an impact just when you work with logs. And the last one is on testing. That remember, there's different types of testing. One of the ones that Anu mentioned today is performance, but you need to think about at least unit tests and integration tests. The reason why I mentioned this is because I just have a couple of scenarios last week on this. And lastly, because we talk about 0.1 and 0.2 pcores, there is one excellent session from this guy here. This is our expert in APAC. It's Vitali. He's a Java performance engineer, and he's working on our support team for more than 5 years already. And this session is 11 minutes into understanding how you can simulate 0.1 and 0.2 pcores in your Anypoint Studio. He also has a astonishing session, if you are into that level of detail, around the JVM and how it works in MuleSoft. So I will post those resources as well. Okay, community. I don't know if there's any other questions. If there are not any other questions, first of all, I wanted to thank you for the time invested today, and thank you, Anu, for being our great spotlight speaker in this session.
Of course. Thanks for having me, everyone.
Thank you very much, Anu, and thank you very much, everyone. The session dead. Have a great rest of the evening and rest of the day. Until next time. Bye, everyone.
Bye.